Hey everyone, here's a video answer key for the multiples and LCM homework that was assigned on Friday. So hopefully you can go through this and just check your errors, and anything that you still don't understand we can talk about in class on Monday. So I had to switch this from the first 10 to the first 5 multiples. Listing multiples is basically like skip counting. And so if I start with 2 and then I go up by 2 every time, it would be like 2, 4, 6, 8, 10, and so on. When you're thinking about multiples, it's also like 2 times 1, 2 times 2, 2 times 3, 2 times 4, and so on. So if I start with 3, 6, 9, 12, 15, so those are sort of the first 5 multiples, I can see that 6 is in both lists, so we would call that a common multiple. And since it's the multiple of the lowest value, then we would call it the lowest common multiple. So 6 is our lowest common multiple, or LCM there. For 8, if I list the first 5, it's 8, 16, 24, 32, 40, 48, and so on. And 6, 12, 18, 24, 30, and so on. And when I look at this, I can see that 24 is in both lists. And lastly, 4 and 10. So I'm going to list the first 5 multiples here. I'm putting the dot 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 because multiples will continue forever and ever and ever, so I just won't stop it. So that's what this means. And then looking at these two lists here, I can see that 20 is in both of the lists. So 20 is the LCM here. Some people think that a way to get the LCM is just by multiplying these two, like 4 times 10. By multiplying these two, you're always going to get a common multiple, but it might not be the lowest common multiple, so just be careful with that. Okay, for question 2, it's really similar to question 1, but we have to find the LCM between 6 and 7. Now I know that 6 times 7 is 42, so that's a potential lowest common multiple, but if I wanted to check, I could list them as well. So 6, 12, 18, 24, 30, 36, 42. And then in terms of 7, I know that none of these here are going to work with 7, so 42 is the LCM. For 15 and 5, I'm not even going to list them because I know that 5 can go into 15. And if 5 can go into 15, that means that 15 is a multiple of 5. For example, 5, 10, 15. These are all multiples of 5. And for 15, 15 is a multiple of 15. So my lowest common multiple for these two is 15. What about when you have 3? So 2, 4, and 5. Now one thing that I noticed between 2 and 4 is that 2 actually goes into 4. And because 4 is a multiple of 2, I'm only going to really look at 4 and 5. So the multiples of 4 and the multiples of 5. And I can see that 20 is a multiple of both of those. It's the lowest common multiple for 4 and 5. And 20 is also a multiple for 2. So I'm going to say 20 is the lowest common multiple for those. On the back side of the page, there's some word problems. So in this one here, I have Kevin, Allison, and Fred. So Kevin works every second day. So he kind of works one day, or not work, sorry, and then he works, and then he doesn't work, and then he works. So for example, he works every 2nd, 4th, 6th, 8th, 10, basically multiples of 2. Allison works every 4th day, so that's kind of like multiples of 4. And Fred works every 5th day. That's like multiples of 5. And if I notice Allison and Fred in my list here, they both match up at 20. And because Kevin works every 2nd day, if I were to extend this as well, I could see that he would also work on the 20th day. So they will work together again on the 20th day. Explain how I know? Well, my explanation of how I know is that I've listed the multiples. But one of the things that I'd like you to start doing for word problems is to end with a concluding or therefore statement. And these 3 dots here mean therefore. So I'm going to put therefore they will work together again in 20 days. Okay, the last question. Kyle bought some $12 shirts and Sally bought some $15 shirts. They each spent less than 200, but they spent the same amount. So if Kyle bought one shirt, then he would have spent $12. If he bought two of those shirts, then it would have been 24. If he bought three, it would have been 36, and so on. So I'm looking at multiples of 12 here. So on, so on. Well, 84. I guess I can keep going. Sally was 15, 30, 45, 60, 75, 90, 105, and so on. So one way I could do it is continue to list these out until I see a number that matches both. But I already noticed that 60 matches for both. Now it says how much could they have spent. It looks here that 60 is the lowest common multiple between these. So they could have spent $60 each. If they spent 60, that means Kevin would have bought 1, 2, 3, 4, 5 shirts, and Sally would have bought 1, 2, 3, 4 shirts. So I could have said 60, but I could also extend this. One thing that we learned today in the hot dog problem was that if you take the lowest common multiple and take multiples of this number, for example, 60, 120, 180, so these are multiples of 60, which is the LCM, these other numbers are also common multiples. So without even extending these two, I can figure out other common multiples. I can show you briefly how we can get to 120. So the next number here would be 120. And here I'd have, what am I doing here, 12. So that's 96, 108, and then 120. So I can prove that that's another common multiple. Every 60, it's going to be another common multiple. So the next one would be 240. But because they each spent less than 200, this one doesn't work. So for the question when it says how much could they have spent, I would say therefore they could have spent 60, 120, or $180.